as, first of all, negative 36 divided by negative 9. Those are common. And then with my x variables, I'm going to keep my base the same, start from the numerator, and subtract the exponent. So 11 minus 6. Same thing with my y, keep the base the same. And for some reason, students tend to gravitate towards the biggest exponent first and write 6 minus 5. Don't make that mistake. Always start with your numerator, even if your numerator is smaller, and write 5 minus 6. Numerator, then subtract your denominator, okay? So what is negative 36 divided by negative 9 going to give me? Raven, what do you think? 36 divided by negative 9. 4. Good. Jensen, what is 11 minus 6? Yes, so x to the power of 5. And y to the power of, what is 5 minus 6? Leanne? Negative 1. Good. So that looks proper to me. Now, we haven't yet talked about the rule for when you have negative exponents. So usually you would never leave this. There would be one more step. We have to, this is kind of like bad grammar in mathematics, having a negative exponent. So there would be one more step to deal with it, but we haven't learned that concept yet. So right at the very end of the seminar, we're going to talk about that. So that is division. Now we're going to move to the power of a power rule. Now, so the rule on the bottom is actually just my power rule. Whenever I have something inside brackets, which I can't simplify further, and I have one power on the outside, that power has to be applied to everything inside the brackets. That's what that means. However, when you have a power of a power, so this is pronounced a to the power of m to the power of n. So see how I'm saying to the power twice? That gives you a hint that it's a power of a power rule. Whenever you have this situation, you only have one base. So that's a big clue. You don't have separate bases. So one base. So my rule starts off the same. Keep the base the same. However, now what we have to do, once we keep the base the same, what do you think we have to do with our exponents? What operation do we have to do with our exponents? Reynard, what do you think? Good. We have to multiply. Multiply the exponents. Okay, so let's start off with an easy example. Negative 7a to the power of 3, b to the power of 2. And all of that is going to be to the power of 3. So notice, first of all, whenever you have something in brackets, you have to verify, before I look at anything outside of the brackets, that I can't simplify anything further inside the brackets, because the a and the b, they're different variables. They can't be combined. So everything has been simplified as much as it can. And now I can apply the power of 3 to everything inside the brackets, okay? So I'm going to take so first of all, I have 3 separate terms that I'm applying the power to. The negative 7, my a cubed, and my b squared. So to each of those 3 separate terms, I'm going to apply the power of 3. And remember, there's no such thing as too many steps. So negative 7 to the power of 3 you could figure out on your calculator. For your Unit 1 test, we're not going to be using calculators. So you have to do -7 times -7 times -7. Then I keep my base the same and I multiply my exponents. Keep the base the same, multiply the exponents. So -7 to the power of 3, is that going to give me a positive value or a negative value? What do you think? How about Matthew? Negative, good. So negative 343 to be exact. And then I have a to the power of positive 9, b to the power of positive 6. So as long as you're breaking everything up into components and dealing with things separately, you're not going to have any problems. The problems arise when you start mixing up steps and applying the rules in the wrong order. So let's look at one more of these. Power of a power rule. Example 6. Negative x squared y to the power of 7, and all of this is going to be to the power of positive 4. So I'm going to apply that power to everything separately inside the brackets. And once again, we can't simplify further inside the brackets because we have different variables, different terms. So I can go ahead and apply my power. Now, what number does the negative sign represent? What specific number could I write in there? Does anyone know? Samita? -1. Good. So I can take my -1 and apply the positive 4 to that. And now I have x squared over y7 that I can apply my positive 4 to. Okay, so -1 to the power of 4, is that going to give me a positive value or a negative value? What do you guys think? Positive or negative? -1 to the power of 4, what do you think? Yep. Positive, good. Whenever it's even, it's positive. Whenever it's odd, it's negative. X squared to the power of 4. I'm not going to add my exponents. I have to keep the base the same and multiply my exponents. Same for my y. Y to the power of 7 times 4. So that gives me a final answer, positive 2 times 4. Chloe, what is that? 8. And 7 times 4? 28. So I have positive x to the power of 8 over y to the power of 28. Okay, still very straightforward. Now I have to do an example with you of the power of a quotient. So what happens when, before I apply my power of a power rule, I have to simplify inside the brackets. So this is called the power of a quotient rule, when you have to apply the power to both the numerator and the denominator. So make sure you write this rule. This is going to be a question that's very important, so put some stars next to it. And then I'm going to write the question on the board. So last year when students were writing the Unit 1 test, I noticed they ran into problems because right away with this type of question,